All right. Hi, everyone. Thanks for joining this session for today. My name is Hussein Awad, and I'm going to walk you through some of the Azure design patterns. Today, we are going to focus on 4 key design patterns, and I would like to call them the gate patterns. They are just related in names, but in concept and in the usage, they are totally different, and they are comes under different categories of cloud design patterns. Patterns for today we are going to cover are GateKeeper Pattern and Gateway Offloading Pattern and the Gateway Routing Pattern and Gateway Aggregation Pattern. We are going to dive deep into each of them and discuss them in more details with practical examples and scenarios. The first pattern I would like to start with is the Gatekeeper Pattern. And the Gatekeeper Pattern comes under security category of cloud design patterns. Usually there are many categories of cloud design patterns, like security, messaging, resiliency, reliability, design and implementation, operational excellence, etc. And this particular pattern focuses on the security aspect of things, and we are going to see this in more details through the examples. And this pattern is all about providing or adding additional layers of security in front of the application layer services to be able to protect it from further attacks. Related patterns to the Gatekeeper pattern is a Valley Key pattern. Let's assume that we have our application layer services. It could be hosted in Azure in anything like Azure App Service or Azure Functions App or Azure Logic Apps. And as I said, this is going to be our application layer services that provide some sort of functionality or features for the end user to consume. It could be a website, it could be an API, it could be any logic apps. And then we will have a SQL database or a blob storage at the backend. So all of these application layer services will have to interact with this backend database storage or blob storage. Then our user or the consumer of our services will have to interact with the application layer services in order to be able to use our service that we provide. So far, so good. We have done everything perfectly as been described by Azure, right? We have database or blob storage been hidden from the external users, and we have an application layer services that's going to facilitate the communication between the external users and the backend components. But there are few risks implied by providing the external user having access to the application layer services of our system. First of them is the external user will know exactly the URL of our application layer services. In this example here, the external user will have to know the endpoint or the URL for the Azure Functions app in order to be able to interact with it. And this is what Azure Function has been designed for. It's a function as a service being hosted in the cloud and accessible through a URL or endpoint. There is nothing wrong with that. But as we said in the beginning of this lecture, that this pattern is about adding additional layer of security to protect certain services. So we want to avoid or hide these certain Azure components from the external users so they don't know exactly their endpoints or what they are. And the risk that we are going to provide or expose the URL to the external users is that the external users might get indirect access to the backend database if they could penetrate our application layer services. And this is what we are going to try to protect by applying this pattern. Also, you could think of if we have OAuth authentication to authenticate the external users with our application layer services, then we will have to implement OAuth authentication within our Functions app. And this is not the primary purpose of this Function app. The Function app is primarily been implemented to cover the certain application layer scenario. So we are going to overload the Function app with adding additional implementation for OAuth authentication. And as a quick implementation, you might think that, okay, if we place all of our application layer services in an internal VNet, we would be able to protect these resources from being accessible over public internet. And then the external clients would need to connect through VNet peering if they are in Azure, or connected through a VPN if they are using or hosted from any other cloud provider or from on-premise servers. By doing so, we have achieved some level of security, but still, the user can penetrate this certain Azure function and can get indirect access to the SQL database. What we have done so far by placing it in an internal VNet, we have protected these resources from being accessible over the public internet. Now, let's see how we can use this pattern to resolve this problem. What we are going to do here is to place an Azure component in between of the external user and the application layer services. And I'm going to use API management. And this could be anything. It could be application gateway, front door, but in this scenario, I'm going to use API management to stress on some points. And then the user is going to communicate with the API management, and then the API management is going to communicate with the application layer services. At that point, the external user will know nothing about the application layer services because all the communication the user is going to have is between the user and the API management. So if we are going to consider the URLs or the endpoint that we have talked about before of our function app and the API management, the user will only communicate with the API management endpoint that will give them or that will execute the functions app at the backend service. The user will never interact with the functions app directly. The user will never know what is the backend service for the API management. And so far, it's a win. By hiding our application layer services and hide our application logic from the user, it's a really good security point we have achieved for our solution. Now I would like to go to a little bit into the API management in case some of you guys are not familiar with it. API management provides us with some out-of-the-box security features that we can use straight away and will make the life easier for us for our Azure Functions implementation. For example, we can enable OAuth authentication in the API management straight away or using OpenID Connect. And this view will help you to understand what's exactly happening inside the API management. In the API management, we have different APIs in our solution. Each API will have different operations, get, post, put, delete, HTTP verbs. And then for each of these operations, we'll have a front end, which is going to be the interface with the external client. And that the front end part is that what the client is going to use to be able to interact with our API. And then we will have a backend part, which is linked to the function app. And as you can see here, this is going to be the URL, the request URL that the client is going to use to be able to interact with our API management. And the client will never need to know any endpoint or any URL for the Azure Functions app to be able to interact with it. And this is one of the hiding or security mechanisms that the API management is providing out of the box. So we see here the endpoint of the function app is going to be used replaced by the API management endpoint. Now let's assume another scenario. Let's assume that we have hosted our backend services as Azure App Service. And of course, the endpoint of the Azure App Service is going to be different in the API management side. So we are going to use a different endpoint at the API management side to allow the users to reach to the Azure App Service. But unlike Azure Functions app, by implementing a custom web service and hosted in Azure App Service, we are going to lose some out-of-the-box security features that's already implemented in the Azure Functions app. And I'm going to touch on them really quickly to help you understand what they are. So this is a screenshot of the response being received from the custom web service hosted in Azure Functions app. Custom web service hosted in Azure App Service. So as you can see here in the response, you are able to see the ASP.NET version and the platform being used. Also, we are able to see the backend or the endpoint of the Azure App Service. So we have 3 points now we need to secure manually in order to make sure that the API management wouldn't leak any information about the backend if we are hosted it in Azure App Service. And the first thing we can do in the API management is use one of the policies or change inbound processing by removing these particular headers from the response. Removing ASP.NET version and removing export by from the response. As you can see in the response here, doesn't have any information about ASP.NET anymore, but we still have the endpoint of the backend Azure App Service. And what we can do about it is to use one of the API management policies and mask URLs in content. And what this policy is going to do is it's going to send the API management endpoint in the response instead of sending the Azure App Service endpoint in the response. By doing that, we are able to reach to the same point of security that's already in place and by default implemented for the Azure Functions app. And getting back to our scenario now, we have placed a layer of security in front of the application layer services to protect it from external users. And as I said before, we can use other components other than the API management. We can use application gateway, we can use Azure front door to facilitate or achieve the same target. And also we can add more than one layer of security. Like we can add an application gateway to accept the traffic from the external users. And then the application gateway is going to send the traffic to the API management. By adding additional layers of security is going to add more protection, not only for the application layer services, but also for the API management. And I'm going to highlight at the end of this pattern some scenarios where you need to combine the API management with the application gateway. So this is the core of the pattern, adding additional layer of security in front of your core endpoints to protect them. And there is no limit how many layers you can add. Of course, as you add many layers, you need to expect more latency to be added to your solution, but there is no limit for doing this. Now let's talk about some considerations you need to keep in mind when you use this pattern. First of all, that the backend service needs to expose only internal protected endpoints. What does it mean is that when we have architectured our system like this, we need to make sure that the external user will have no access to the API management, right? We have placed an application gateway in here to protect and add further protection to the API management. We don't want the external users to be able to turn around the application gateway and access the API management directly. And same concept, we don't want the external users to be able to turn around the API management and the application gateway and access the application layer service directly. And we should be able to achieve this by placing these components in internal VNets. So it's going to be one part is have restricted access to these components by placing them in internal VNets. And also you need to apply different authentication, authorization mechanisms to these components, in addition to specifying access restriction policies, which is very, very important. The access restriction policies is going to restrict the application layer services to accept traffic only from the API management. And similarly, the API management is going to accept the traffic only coming from the application gateway. If the client could be able to reach to the API management and send the request directly to the API management, it won't be accepted. Also, a very common security best practice is to run the gatekeeper or run these extra layers in the minimum or least security privilege. We don't want to assign too much power or privilege to these gatekeepers we adding to our solution. Also very important to not to add any business logic in the gatekeeper. The main purpose of it is to act as an additional layer of security, not to segregate your business logic across many layers, which is going to confuse your solution and make the maintenance harder for your code. Also, you need to consider the SSL offloading. SSL offloading means like when the client communicates with the API management using HTTPS, encrypted traffic. We will do the SSL offloading at the API management and continue the traffic HTTP internally through other Azure components. We usually do this to enhance or increase the performance because all of these communications between all of these services are internal communication. It doesn't need to be secured as the external communication. In some situations, you can achieve this and you can do this. However, in some requirements, you might have to do end-to-end encryption, which restricts you to have an encryption between the user and the database. So all of these communications should be encrypted using HTTPS. At that point, you shouldn't do the SSL offloading at the API management. Instead, you need to do it at the SQL level or at the database level. As I said before, you need to expect additional latency to add to your solution. However, it's going to be milliseconds by adding these additional layers of security. But bottom line is there is additional latency we need to be aware of. Also, by using this pattern, we will introduce a single point of failure. If the API management instance has gone down for any reason, the external users will lose the access to all of the application layer services, right? And we can mitigate this risk by initiating or deploying multiple instances of our API management in different regions to make it highly available and to make sure if one of these instances gone down, it won't affect the whole solution. Now let's see when you should use this pattern. This pattern, as I said, to add additional layer of security. So if you want to protect certain application components or services, you should consider using this pattern. Also, when you want to perform a validation separately from the application logic. One of the powerful things about the API management, it allows you to perform a validation at different things: content validation, parameter validation, response code validation. So you might need to do all of the validations in the API management instead of doing it in the functions app. And also you want to aim to have all of the validations in one place. I'm not talking about the validation of the whole system. Of course, you need to do the validation at every layer of your solution, at the UI, at the business layer, at the database, to make sure that not any corrupted data is going to be written to the database. But what I'm talking about here is to concentrate all of the application in a certain layer. You are focusing all of the data validations to be in a certain area. You don't want to segregate some data validations to be in the API management and the rest of the data validations in the functions app, and then you get confused and get lost where is where, and you forget when you need to do any maintenance for your code. That's all you need to know about this pattern, and hopefully it's now clear for you what does it mean by adding additional layers of security to protect our application layer services and what's the purpose of it. Now I would like to go to the second pattern, and probably I can pause for a few minutes if there is any questions or someone have any questions. They can put it in the chat window so we can chat a little bit about it. Right, let's keep going and we'll see the questions as they coming through the chat window. The second pattern we are going to talk about is the gateway aggregation pattern. And this pattern comes under design and implementation and operational excellence categories of cloud design patterns, and they are about to aggregate multiple individual requests into one single request. And there are related patterns to the gateway aggregation pattern, like backends for frontends, gateway offloading, and gateway routing. Today, we are going to cover the gateway offloading and gateway routing, as I said in the beginning. Now let's talk about some examples to help us understand this pattern better. Let's assume that we have multiple services, service A and service B and service C. All of these services could be implemented using Functions app or Azure App Service. Then we have an external client that needs to perform one task. And to perform that task, he needs to interact with 3 services, A and B and C, all of them to perform one task. And this is the first challenge we have in here. Now, we are exposing a lot of our system architecture to the external user, so they know exactly what services they have to communicate to in order to perform one task. And also, it's harder for the client to communicate with multiple services and aggregate the responses back to determine whether his request or the task has been succeeded or not. It would be easier for the client if there is something in between here that takes one request from the client and respond back with one response, whether it's succeeded or failed, right? Also consider a scenario that the task has been expanded and would require to get some information or to update some data in service D. Then the client will have to update their code to be able to interact and communicate with service D as well. So it's going to be a lot of operational effort for the client for every time we update our task with additional services. And this is the challenge that the gateway aggregation pattern is trying to solve. How we are going to make the life easier for the client, and how are we going to protect our service architecture from being exposed to the external users. And as I said before, this pattern is about adding a gateway or adding a box to be the interface between the client and the rest of the services in our system. So the client will just send one request to our gateway aggregation, and then the gateway will be responsible to send the requests to all of the services and aggregate the responses back and send back to the client only one response about the task, whether it succeeded or failed. And then if the task has been expanded and we needed to add another service to the task, then the user will not need to do anything, because his interaction with the gateway, all of the changes we'll need to do is on our side to update the gateway to call or update the service D. And as I said before, all of these services is part of the our system architecture. And by doing that, by placing the gateway aggregation in here, we are hiding all of our services from the client. All of these services could be Azure Functions app, for example. And the gateway could be Azure Durable Function. And if you haven't heard of the Durable Function before, it's an extension for the Azure Functions app, but it has a different lens. It's very similar to the AWS, what it's called, Lambda function or Functions app. That allows you to call multiple functions at the same time with a longer execution time that spans for 24 hours. Now let's have a look at the durable function to understand it a little bit. As I said, it's an extension of the Azure Functions app to help you write stateful functions in a serverless environment. And there are different implementation patterns already been highlighted from Microsoft for the best use of the durable functions. We are going to touch on them quickly because they are not the main purpose of this pattern, but to help you understand which durable function pattern we can use in our pattern for today. The most common one is fan out, fan in. When a request comes in, we spread it across multiple functions, and then we aggregate the response back to send it to another function. And this is exactly what we have talked about in the aggregation. We just need to aggregate multiple functions up into one request and one response. Also, there is a function chaining. This is when the output of one function is going to be the input of the another function, and so on. And also, it could be used for asynchronous HTTP API, or for monitoring other Azure Functions app, or have a human interaction, like if you have a workflow that could expand for 24 hours and it would require someone to go and approve or reject or do something in the process. The durable function is the best implementation for this. Also, it's used for as an aggregator for multiple requests. Now, getting back to our scenario, and I have put in here the fan out, fan in pattern to help you understand that this pattern is very related to the aggregation pattern gateway aggregation pattern we are talking about. So the client is going to send a request to the gateway. The gateway is going to fan out the requests to all services related to this task. And once all of these services finish the execution, gateway is going to fan in all of the responses from these services to send the response back to the client. As I said, it's going to make the life easier for the client, it's going to secure our system, it's going to make our system much, much easier to use and to maintain. Now let's talk about some considerations you need to be aware of when you use this pattern. The backend service coupling. What we mean by coupling is a dependency between a service and another. And what's happening here is we have the gateway is calling service A, for example. What you want to avoid is to have a service A needs to call the gateway back for any reason. So it's going to be a circular coupling between the gateway and the backend services, and you don't want to do that. Also, you need to expect some latency because we have added additional layer in front of the backend services. That's going to be aggregating all of the requests and response. There are additional latencies going to be expected in this. However, when you place your gateway, you need to place them as close as possible to these services. You don't want to host these services in Azure, Australia East region, and have the gateway in Central US. It's going to have a lot more latency and a lot more traffic than placing all of them in the same region. Also, you should consider having a single point of failure, but by having the gatekeeper responsible for getting the responses and responding with the responses. And we can mitigate this risk by having multiple instances of the gatekeeper or the gateway aggregation. Also, it's going to be a performance bottleneck because all of the requests is going to come into the same place. So you need to consider the scalability plan for your gateway aggregation, how you are going to scale it when you get extra load. Also for the load testing. Of course, we are doing a load testing individually for each service individually in our system. But what we need to do now is to do a load testing at the gateway aggregation level. We have tested each of these services individually, and we have got the performance metrics for all of them. And we know exactly how many requests each of these services are able to perform. But we need to perform a load testing at the gateway aggregation level, because this is going to be a single entry point for all of our system. And we want to see and assure how the performance is going to look like for the external user perspective. How many requests the external user is going to be able to perform when they communicate with the gateway. So load testing should be performed at the both areas. Also, you should consider using other design patterns like bulkhead or retry to add more resiliency to the gatekeeper, to the gateway aggregation pattern. Also, you should consider if it's okay for your business stakeholder to return partial data. For example, if service D is unavailable for any reason, is it okay for the gateway aggregator to return the data from service A and B and C only and ignore service D because it wasn't available? That's a business decision that you need to make with your stakeholders. Also, you need to be aware that you need to apply asynchronous I/O requests between the gatekeeper and the backend services. Also, you need to apply distributed tracing all the way from the client to the gatekeeper to the gateway aggregation, and from the gateway aggregation to the backend services, and have correlation IDs to help you track these requests. And you need to monitor the requests and responses from the client and the responses that the gateway aggregation is going to respond with. And also you need to think of if you can return a cached data as a failover strategy. The scenario that we have talked about before, if service D is unavailable, is it okay to return partial data, or it's okay to get some data cached and return a cached data? These are the different things you need to be aware of when you use this pattern. Now let's see when we should be using this pattern. When the client wants to communicate to multiple backend services to perform one operation, we are going to make the life easier for them if we have one entry point that's going to interfere with all of these backend services instead of the client has to go through all of these backend services. Also, when the client is using a network that has a significant latency, like a mobile networks, it's going to be much more efficient to have one single endpoint to get the request and respond back with the result. And when you shouldn't use this pattern, if you are trying to do a large number of calls to a certain service. In this situation, it's going to be more efficient if you use a batch operation rather than just use gateway aggregation, because at the end, you have only one backend service to interact with. Also, if the client or the application is located closer to the backend services, there is no need to introduce an gateway aggregation pattern in between, because it's not going to be a significant factor. Now, this is the gateway aggregation pattern. Again, I'm going to look at the chat for a few minutes to see if there are any questions someone wants to send before we move ahead to the next pattern. All right, let's keep moving. Then we have the gateway offloading pattern. And this pattern comes under design and implementation and operational excellence. And it's about offloading shared or specialized services to other Azure components. And we are going to see this in more details. Related patterns are backends for front-end, gateway aggregation, and gateway routing. Now let's assume that we have a service. Our system consists of two services, service A and service B. And we have a user that needs to interact with those services. If we have a deep dive into those services, we will see that we will have to implement other things, many other things, in addition to the core business functionality of those two services. We will have to have a token validation that's going to validate the token that's been sent from the user. Also, we are going to have some encryption being handled by the user. If we are going to encrypt the traffic between the user and our services, we will have to implement an encryption handling module in our service to allow it to communicate with the user. Also, if we are using a client certificate to secure the communication between the user and our services, then, and if we consider to do the SSL offloading in the service A or just continue the traffic encrypted, so either way, we will have to have a sort of SSL certificate handling in our service. And of course, more importantly, and it should be the first one that I would start with, authentication. When the user is interacting with our service, we need to know exactly who they are that they are interacting with our service. They have to have a username or password, multi-factor authentication. Even better if we are leverage Azure Active Directory or use managed identities to have a passwordless authentication between the users and our system. And when we mention authentication, we cannot ignore authorization. We need to specify or know what access the user has to perform on this service. Also, we need to have some sort of logging, different requests and responses that have been sent from the user and the responses that our service responded back to the user. And also we need to have a significant monitoring about our service and with alerts to notify us if there is any abnormal activities happening on our service. And also we need to have or implement a throttling mechanism to protect our service from if one of the users decided to flood our service with too many requests. And as I said before, all of these modules or parts needs to be implemented in addition to the core logic, business logic of service A. And also, we will have to do all of these modules being implemented in service B as well, right? Which is going to be a huge amount of effort and duplication in our system. This is exactly the challenge that the gateway offloading pattern is trying to solve. Looking at all of these parts here, we will know already that some of these can be offloaded from our services, and we put it to someone else that's more specialized, more highly available, and can perform it way better than us. And then we are going to start and see how we can use these external components to offload these modules from our services. Now I'm going to focus on service A and start offloading these certain components from it, and what applies to service A is going to apply to service B as well. The first one I'm going to take out is the introducing Azure Load Balancer. And by adding Azure Load Balancer, we are going to receive encrypted traffic from the user, and then we are going to perform the SSL offloading at the load balancer side to continue the unencrypted traffic between the Azure Load Balancer and our service. And by doing that, we would be able to offload SSL certificate handling from our service because it's now been handled by the Azure Load Balancer. So we don't need to implement it ourselves. Also, as I mentioned before, we can use Azure Active Directory to help us in many features by directing the users to authenticate using Azure Active Directory, and then the Active Directory is going to direct them to our service if they are authenticated or authorized. And by introducing the Azure Active Directory, we can offload many modules in here. We can offload authentication, authorization, and token validation, which is going to make the life much easier and simpler in Service A. Also, when we think of Azure Applications Insight, which is helping us in monitoring to detect the performance metrics of our service, how many errors we are getting, what is the availability ratio of our service. And by using Azure Applications Insight, we will be able to offload the monitoring part from our service and just totally offload it to the Applications Insight. Similarly, using Log Analytics Workspace, which covers all of the logs metrics happen to sent and received from the service. And by doing this, we would be able to offload the logging module from our service. So we don't need to worry about it anymore. Also, by introducing Azure Key Vault, which is a secure way to handle and manage secrets and certifications in Azure. By doing this, we would be able to offload the encryption from our service. And finally, for the throttling, if we are using an Azure API management, we could specify a throttling limit, whether it's per subscription or per user or per product or per quotes that could be downloaded per minute or per second. By doing this, we can offload the throttling logic to the API management. Or also, if the service A is a functions app, we can implement the throttling at the function app level as well. Also, API management has one of the authentication policies that allows you to perform a token validation, GWT token validation, which could be similarly equivalent to the Azure Active Directory. Now, by offloading all of these modules from our system, and then we should be able to use all of these, and I forgot to mention, like, we also are able to perform SSL certification offloading, SSL certification at the API management level, in addition to the Azure Load Balancer. So these are additional things that could be handled in the API management as well. Now, when we offload all of these components to all of these modules to other Azure components, now we can leverage and use all of these across all of our services. Now, our services wouldn't need to worry much about all of these components or all of these implementations. It just will focus on the core implementation of their logic. And this is the biggest benefit of this pattern. Now, let's talk about some considerations you need to be aware of while you're using this pattern. High availability is a big concern. You need to make sure that the offloading components that you are using are highly available. For example, Azure Active Directory is highly available. So you want to use or aim for a highly available service when you offload your modules to these services. Also, you need to consider the scalability for these offloaded service. How those services should be able to handle the increased workload for your system. Are they able to increase or scale as the user load increase? Also, you need to offload certain features that are used by the application. If there is one particular feature that's just used by one module in your service, you don't need to worry about it. You need to look for the commonalities and you need to tackle the most common modules that's used across all of your services in your system, and you want to aim to offload these modules to other Azure components. And one thing you should never do is to never offload the business logic. These components or these services are to offload certain functionality, logging, monitoring, encryption, throttling, etc. It's not meant to offload the business logic. Business logic should all remain in your services at all times. Also, because there are too many links between the services and other Azure components, you need to maintain correlation IDs to help you to track the transactions between the user and the offloaded components like Active Directory or Load Balancer or API management and your service. Now let's see when you should use this pattern. If you have a shared application deployment features like SSL, encryption, throttling, authentication, and when you have a common features across application deployment that have a different resource requirements. Also, when you want to move the responsibility to another team, by moving the SSL offloading from your service to the Azure Load Balancer, and probably you can give it to the networking team to handle the Azure Load Balancer with the SSL offloading altogether, and free your development team to focus on the core application implementation. Now, this was the gateway offloading pattern. And again, I'm going to pause for a few seconds to see if there are any questions might be coming on chat. All right, let's keep going. The final pattern we have for today is a gateway routing pattern, and it comes under design and implementation and operational excellence categories of cloud design patterns. And this pattern is about routing requests to multiple services using a single endpoint. And the related patterns are backends for frontends, gateway aggregation, gateway offloading pattern. Now let's come to the examples to help us understand it better. Let's assume that our system consists of multiple services. Let's assume search service, order service, review service, and cart service. And all of these services could be implemented using Azure Functions app or Azure App Service. Then we have the external client that's going to interact with all of these services. Each of these services will have its own endpoint that the client has to maintain in order to be able to communicate with this particular service. And what if we have decided to change our system architecture and split review service, for example, into two separate services, internal review service and third-party review service? In this case, the user will have to change their code and interact with each of these services separately, the internal service and the third-party review service, which is going to be an ongoing overhead on the client, right? And this is one of the challenges. The client is going to be very linked to the system architecture or service architecture of our solution. And for any change we are applying to our service architecture, the client most probably will have to do some change at their end. Now, let's see how can we use this pattern to improve this situation. by introducing the gateway in here to be the single place that the client is sending all of his requests. Then according to the path-based routing, the gateway is going to send the request to the particular service based on the rules defined, and we are going to talk about it in a minute. This gateway could be application gateway, could be Azure front door, for example, to act as a single place or a single contact for the user. And then the user will have, so for example, this gateway will expose these endpoints for the user to consume, and then the gateway will route the request to the particular service. Now, the question is how the gateway will know which service should handle or should be the end of a particular request. And to understand this more, let's have a quick look at the Azure front door. And in Azure front door, there is a front end, which is going to send the traffic to backend pools based on the routing rules. So we have one front end domain, and we have multiple backend pools. And based on the routing rules, we will define based on a certain path-based routing or IP address or etc. We are going to assign or direct the user to one of these backend pools. And to have a closer look about it inside the application gateway, for example, we will get to specify the internal or external. So for example, in here, in the routing rules, we will get to specify the backend target. For example, it's going to be an API management. And if you see in here, the internal traffic is going to go to sync pool, while the external is going to direct it to the API. Don't worry too much about it. It's just to show you how we can apply different path-based routing or rules to help us direct the traffic to certain areas. And this is where we can specify the path in our endpoints. So according to this, we can apply path-based routing for this endpoints. So when the user sends this URL, the green one, we should be able to send it through to the search service because we know exactly that this URL is meant to send to the search service. Now, let's consider another scenario. Let's assume that we had a new version of search service. I know that both functions app and app service has a versioning mechanism inside them. Leave that aside for now. I just want to highlight a certain point. Let's assume that we have a separate search service 2 has been deployed in a separate Azure service component, separately from the original one. And what we want to do here is to allow the user to use search service 2 without making a much disturbance. And what we can do in here is to, instead of the gateway routing sending the traffic to the search service, we are going to update it to send the traffic to search service 2. All of this, the client will use the same endpoint all the time. The client wouldn't need or wouldn't notice any change in the endpoint or in the interaction that he is interacting with our system. And in any failover scenario or some error might happen in search service, we might be able to revert the traffic back to search service. Again, the client wouldn't notice any difference, which is win. And let's consider another scenario for the review service. As I said here, we have introduced the single review endpoint for the client, but we have changed our service architecture to introduce both internal review service and third-party review service. In this case, which of these services are going to be used to return data to the client when they communicate or request this URL? And I'm going to recall the gateway aggregator pattern in here. Now, when the user sends this endpoint, review endpoint, we're going to have a path-based routing to the gateway aggregator, which could be a durable function. And then the gateway aggregator is going to communicate with both internal review service and third-party review service and aggregate the response back and send it to the client. Now, you might ask a question, can we use the application gateway or front door straight to send the traffic to both services? The question is yes, technically you can, but the problem is the front door or the application gateway has been implemented to send the traffic by weight. So for example, you are going to specify you want to send 50% of the traffic to internal review service, and the other 50% of the traffic to third-party review service, which is not right. Azure Front Door application gateway are not load balancer that balances the load to all services. And you need to make sure that you are using a gateway aggregator that you're communicating to both services, not either or, which is in the load balancer. You need to communicate with them, both of them at the same time. So you shouldn't use front door or gateway or a load balancer to fulfill this action, and we need to use gateway aggregator in this. Now let's talk about some considerations you need to keep in mind when you use this pattern. First of all is a single point of failure. By introducing the gateway in here, whether application gateway or Azure front door, we are having a single point of failure for all of our services. If the gateway is down, the user will lose all communication with all of our services. Also, it's going to be a bottleneck. So you want to make sure that you are able to scale your gateway layer as much as required, and it will be able to handle the load from your users. Also, you need to perform load testing individually for each of your services individually, in addition to the gateway level as well. And one of the key things about the gateway routing, it operates at layer 7. It's like if you are using like Azure front door, it operates at layer 7 in HTTP. It's not the TCP or IP traffic. Now, when you should use this pattern, when you have multiple services that can be accessed behind the gateway. It's pretty much like the examples that we have talked about already. Also, when you want to introduce a single endpoint for the clients to use to make the life easier for them. Also, when you want to route external requests to internal virtual endpoints, like VM ports, for example, in a cluster. Now we have covered these 4 patterns for today. Again, we have covered the GateKeeper pattern, gateway offloading pattern, gateway aggregation pattern, and gateway routing pattern. As I said, they are relative in names, but they are totally different in concept and in principle, and they are all used in different scenarios and in different situations to achieve certain targets or goals. You can combine some of them in one implementation of your solution. You can combine them with other patterns, as I mentioned, like retry or bulkhead. They are very, very useful to be used or implemented in your system. Now I'm going to put a link for my YouTube channel in the chat window if you would like to go ahead and subscribe and follow the other videos that I have done already on my channel. Now we are going to open questions. If anyone wants to ask any question or wants to put any question in the chat window, more than happy to answer them.
Hussein, there was one question from Rahul.
Yep.
I believe it was during the first pattern, like when you presented the first pattern.
Okay.
That is, can we use?
Yeah. Yep, I got it. Can we use Traffic Manager or Front Door instead of API management? Yes, absolutely, we can. The main idea of this pattern of the gatekeeper is to hide the backend services. Front door could be used instead of the API management. However, you are going to lose some of the out-of-the-box features that the API management provides, like not sure if you are very familiar with the API management, but it has a lot of policies that will make the life much easier for you to implement the throttling limits, authentication, authorization, all of these things. But yeah, technically we can use front door or application gateway instead of the API management, but it's gonna be better if you use the API management to get the benefits of all of these extra policies that already implemented in place and make the life easier to integrate with different APIs. That's a good question. Probably we can wait for a few minutes and then I hand it over to you to carry on the next session for the day if they are ready. What do you think, Kassim? Yeah, sounds good.
Yeah.
Beautiful.
Yes. So Zen, thanks a lot. Thank you very much for your time.
No worries.
And it was really a great session, very nicely and explained in very detailed one. Patterns are very important. I know, like we all know what role it plays when we put on the solution and we put on the things. And really, it was great to have this session from you.
My pleasure.
Kassim,
yeah.
Yeah, I have one question over.
Sure.
It's related to the gateway aggregation and the difference with the fan out and fan in pattern that we used to implement in functions, Azure functions. So, how this is different and the exact scenarios where we can go for the gateway aggregation than the fan out fan in.
Yeah, that's a good question. So the exact scenario for it, when you want to have, assuming like, probably I'm gonna refer back to the diagram to make it a little bit easier. So assuming that you have 5 or 3 Azure functions, that all of them needs to be called or implemented to achieve one action, all right? So all of these 3 needs to be implemented or executed separately. And we need to get the result from all of them in one call. So this is where we are going to have a single endpoint or a single execution or single function, which is our durable function here, which is going to be called. And within the durable function, it's going to send different requests to all of these functions app separately. And then some of them can be responded or executed very quickly. Some of them might take a longer time. And then it's going to aggregate all of the responses and outputs from the functions app to the durable function to send back one response. Does this answer your question?
Yeah, so this is what the fan out, right? Fan out
Yes.
and then fan in. But then how it's different than the aggregation, the gateway aggregation?
Yep, that's a good point. It's not different. It's a way for implementing, like when I said the gateway aggregation, I showed the fan out, fan in to implement it because that's exactly a way for implementing the aggregation, okay? It's fanning out the requests to multiple services and then receiving them back again, fanning in into the gateway in the durable function to send back one request. So the output of all of these services are going to be sent to that durable function in the gateway. So that's the fan-in part that we are talking about.
Oh, okay, understood.
Makes sense?
So
Yep.
yes. So it's a enhancement, I would say, right, over the existing fan out, fan in. So aggregation is an enhancement. That's what you are saying, right?
It's a way of implementing the fan out, fan in. Like if we like this exactly an implementation of the aggregation pattern in the fan out, fan in.
Okay,
Yeah,
understood.
makes sense?
Thanks. Makes
No
sense.
worries.
Yes.
Pleasure. All right, Kassim, I think we can hand over to you now.